Hannes Reinecke, and today's talk is about virtualized FibreChannel. It says 2 years later because I had a similar talk 2 years ago in Prague at the KVMForum. And so this is basically a slide, a presentation, what happened afterwards. So, where it all started. So, Paolo and me had a presentation in Prague 2 years ago, where we discussed how we could virtualize FibreChannel, or to be precise, how we could efficiently virtualize FibreChannel NPIV. For this, we came up with 3 possible options. The one is a LUN-based, meaning a device-based NPIV pass-through. The other would be to use a mediated device, or the mediated device framework to delegate pass-through to that. And the third option, obviously, would go full throttle and implement FibreChannel handling in vhost. So, there were quite a few acronyms and TLAs in there, and also quite some concepts where I'm not quite sure whether everybody here is very familiar with. So I thought, right, do a short recap. So, I mean, FibreChannel, you might or might not have heard. That's basically a SCSI transport. This is at this time, the most commonly used transport protocol for storage arrays or for larger storage installations in general. So this is being nowadays on the, well, there is now a new protocol on the horizon, that's NVMe, or rather NVMe over Fabrics, which you might have heard too. So, and this is basically the predecessor of that one, or still the most commonly used ones. So, to make this work, there are things called FibreChannel HBAs for host bus adapters, which essentially are just your PCI cards which you plug into the server, which then connect via the actual FibreChannel to the storage array in the back. And the whole infrastructure in between, meaning between the FibreChannel HBA and the storage array, is called a SAN, or storage area network. If you do this, these devices will show up just like normal SCSI devices. So this is here now a very short overview how things do look from the Linux point of view. So we have the FibreChannel HBAs and the FibreChannel port, which is the physical port connecting to the SAN. Then there's the HBA driver, which typically is a PCI device, or a driver for a PCI device. And this then generates an internal structure called SCSI host, which then, again, provides all the SCSI devices like here, outlined like SDA and SDB. Good, that was easy. But this has the problem that you need to identify the FibreChannel port. And because it is actually a network, that's why it's called storage area network. So within the network, you need to identify the individual ports. To do this, there's a thing called WWPN, or Worldwide Port Name. And it's partner WWNN for Worldwide Node Number. So these can be thought of, well, essentially like MAC addresses on the network world, and they are typically programmed into the HBA. Because, well, you need a unique identification because it could be global, your whole entire network, so are actually required to be worldwide unique. That's the WW in front. And to guarantee that they are indeed unique, they are programmed into the HBA so that they can ensure that nothing will go wrong there. Which is okay, but in the end. And these port numbers are used on the storage array side to create ACLs, so that the storage array can identify which devices want to talk to the array and then can associate devices or volumes with that device. So the idea here is that each port number represents a machine, and so this machine can access only those volumes which are meant for this particular machine. Again, sounds quite nice and sounds quite reasonable, and that's what you want to do. But then you want to install a virtual guest on your machine. And this is where the whole thing becomes iffy, because suddenly the port number you have doesn't actually represent the machine anymore, but rather the host within which that virtual machine is being carried in. So what you really want is to have an identification for the virtual machine too, so that the storage array in the back can set up proper ACLs and can do the volume association. And to do that, they have created in the Fibre-channel specification a method where you could assign virtual port numbers. That's the so-called N-port ID virtualization, or short NPIV, which allows you precisely that. So you can set arbitrary port numbers on top of a given SCSI host, and then these port numbers will be visible on the SAN, and you can do the storage array, can do ACLs and LUN associations, and everything's nice and dandy. So, and here's now the same schematic than I had previously. So now we still, again, have the Fibre-channel port over there, and the NPIV port, again, visible on the SAN, the HBA driver, which does the handling, the SCSI host, and then the NPIV device shows up as an additional SCSI host beside the original one. Why is that important? Well, the point here is the HBA driver is the same. This will not duplicate, so we only will have one HBA driver and one instance of the HBA driver. And as this HBA driver is that one for the PCI device, we can't really do tricks like VFIO here, because that would mean that we would have, well, several VFIO instances running on the same PCI device, which I have been told is not possible, or not easily possible. And even if you wanted to do so, you still would not modify the driver so that it can handle multiple VFIO instances. So it is not very easy, and actually not something which can be easily done. So, what do we do? I had been looking at the first option of the threes, how we could do a device-based NPIV pass-through. So, the general idea is to, well, you know, the KISS principle, keep it small and simple. We already have SCSI, and this transports the SCSI CDBs and works perfect, so blah, blah. So we should just use it. But to make sure, to tell the guests that we are running on Fibre-channel, we actually might want to expose the Fibre-channel structure to the guest, so that the guest sees, I'm actually now on Fibre-channel, and this is my port number, because the guest might be needing it. And we might want to actually see the physical LUN numbers on the guest too. So, using virtio-scsi as a protocol, that is quite easy. I mean, everyone knows virtio-scsi, hello Paolo. And this just transports normal SCSI CDBs over Virtio. This is pretty nice, pretty generic, but doesn't have any transport-specific information. So we simply have no way how we could transport the port names and node names over Virtio yet. So, but if we want to expose the Fibre-channel structure to the guest, we need precisely this. So we need the port number, we need the node number, so that we can expose the structure. And typically, you would need the full-blown stack with the Fibre-channel handling, port handling, blocking, scanning, whatnot. But Hyper-V had the similar problem that they don't really have an actual Fibre-channel, but still want to make it look like a Fibre-channel. So they had a very lightweight, simple transport class, which just required them to pass in the port names, and then they would see the Fibre-channel structure. And I said, hey, that's a good idea. Let's use it too for Virtio. So we could just use that and tweak virtio-scsi to return us the port numbers, because really that's all what we need. And to do that, I've implemented a Rescan protocol. So the idea is quite simple. Instead of having Virtio itself identifying the devices, we have a protocol, a sequential protocol allowing the host or the emulation to enumerate the devices. So I send a request down, that's the request structure, the Rescan request structure, get me your first target, get a reply, okay, here's the target, here are the port numbers. So this is what you see there. So you get a reply with the ID, which is the number, the target number, and then the port and node number. And so you just issue a command setting the next ID to -1, meaning, right, okay, give me the first one, then you get a number back, and then you just reissue the command with that returned number +1, indicating, right, I want to see the next target. If it has the next target, you get the next target with the set number, and if not, you get -1 back to telling you, right, okay, no next target, screw it. So, which is quite simple, and as you can see, a dead simple protocol. And with that, you have your port numbers. And you can export the port numbers, and you can see the port numbers in the guest. So, if you have paid attention closely, I said something about normally SCSI would be, the virtio-scsi would enumerate the devices itself and ask the host and indicate to the host which device I want to talk to. So how is that? Well, this is because virtio-scsi has a particular format how the LUN numbers are supposed to be laid out. So for virtio-scsi, it's actually using this so-called hierarchical LUN format, where the first, you see there, that's where it says bus identifier, indicates on which bus to look, and the second one, where it says target or LUN, indicates which LUN number on that bus. So the LUN number being passed down is actually an index into the QDIF structure, which device to look for, or which device this command is being targeted for. Which is okay, but it also means you have to use that structure, otherwise Virtio won't find any devices. Which is a bit annoying because the LUN number is also something which is actually a property on the emulated target. So we can't use the LUN, or can't see the LUN numbers from the actual target. Which is a bit annoying, to say the least. Plus, if we have the rescan mechanism, we don't actually need those things, the first two numbers anymore. So, and the other problem is that there's a problem called report LUNS, telling you which LUNs are present, which typically is a command you send down to the target. But as you have an emulator format, you can't send it down. Or the results you're getting back won't match with whatever you need to send, which also is a bit annoying. So what I did is to update the virtio-scsi LUN format, seeing that we are only using ever the first byte, the first 2 bytes of the structure. So there are some bytes left which we could use. So what we can do, we can shift the original LUN behind the virtio-scsi LUN. With that, we're having the first 3 LUN levels, and the fourth, because actually there are 4th levels you can have, the 4th level, well, will be left out. Which you think, that's not so good, what do we do with the 4th level? And the answer to that one is quite simple, ignore it. Because there is no implementation using the 4th level. You do get implementation using the 1st and the 2nd level. Rumors have it NetApp is now using the 3rd one, but that's about it. No one is using the 4th level. So it's essentially 0, and as such, we don't need to use it. So, and with that, ta-da, everything works. However, we might want to update the virtio-scsi spec, indicating, incidentally, there might be something behind the original LUN number. Do we need to update it properly, or can we just have a patch? And if we need to update the virtio-scsi spec, what do I need to do it? Which would be more a question to over there. So, but anyway, this whole thing works. The patches I've sent to the mailing list actually 1.5 years ago. And since then, they are lingering there. I will be resending them. I've just revamped it to the latest version. I will be resending them later today or on the weekend. And then people can start looking at them and bitching about it. But with that, on that happy note, I'm done. So thank you for listening, and I'm open to questions. Okay, thank you very much.
Thank you.
And enjoy the conference.